anesthesia machines have been a staple of American surgical technology for years, but it's not a static piece of equipment. We're here in the ECRI lab to talk to Brad Bonnette about how the technology has changed over recent years, how our testing of those machines has evolved to keep pace, and where we see things going in the years to come. Brad?
Hey, Paul.
So we're here with an anesthesia machine, and I think one of the first things we want to talk about is, how is this piece of technology different than it would have been 5, 10, 15 years ago?
Yeah, it's a good question, Paul. So we have looked at maybe 10, close to a dozen anesthesia machines over the last 5 or 6 years. And the technology has really been improving over that time. And one of the things that we've seen is some really interesting safety features have gone from rare to essentially standard of care. During anesthesia care, you're providing anesthetic agent to the patient, and that's typically stored in the vaporizer in a liquid form, and then it's turned into a vapor when it's delivered. And traditionally, the way the anesthesia provider would know that this level is running low is you have this sight glass here where it's just the liquid level, you can see the liquid level inside, and that's typically sufficient. And you also have alarms that would tell you if it drops too low, and it measures the gas and would tell you it's low. But if you miss those things, then you could have the patient conceivably wake up in the middle of the case, which, as you can imagine, would be bad.
Yeah.
So some of the newer machines, including this one, have the ability to electronically measure the amount of liquid in the vaporizer. It will show you as a representation on the screen, but more importantly, it will alarm when it gets low. So you get the alarm before you get to it's empty, and now your patient may wake up any minute now. You'll get that alarm with 10 minutes or so warning that you can refill it. And we consider that a key safety feature that really differentiates the devices that have it from the ones that don't. So that's been one of the big changes.
What are some of the things that we're looking for that could go wrong and, obviously would then jeopardize patient care?
Yeah, a really good one is something that ECRI has been leading the way on for a long time, and that's surgical fires. So we have done many investigations of fires that have happened in operating rooms over dozens of years. And one of the contributing factors to that is the way oxygen is delivered to the patient. Okay. And what can happen is these units aren't just used for intubation. The patient is intubated and the ventilator is breathing for them. Often you will do a case where the patient is maybe sedated with an IV agent,
okay.
an IV medication, and they're still breathing on their own. So they don't need to be connected to the ventilator, but you still want to give them some oxygen to help out as if they're, to help to keep them healthy during this procedure. And so you don't need all of this equipment. And so instead, all of these units have some way to give auxiliary oxygen, maybe through a nasal cannula or a mask instead of an endotracheal tube. And you don't need this whole equipment for that.
Right.
But if it turns into, if things go bad and you need to open the patient up or go into a more invasive procedure, it's great to be right there.
Sure.
So they call that monitored anesthesia care, MAC. And so, but what can happen though is if you're delivering oxygen through a nasal cannula to the patient, that oxygen is accumulating around the patient's face and is creating an oxygen-enriched environment. And so then if you are also firing an electrosurgical unit near the patient's face, maybe during a plastic surgery procedure or something, and especially if there may be some alcohol prep solution or something that hasn't had time to evaporate, you've got all three elements of the fire triangle, and then you can have a fire.
Yeah.
So there are lots of things that teams can do to make that less likely, but one of the things the equipment can do is, this doesn't have to be 100% oxygen. And if you give air or 50% oxygen, 30 is really the key. If you give 30% or below, the chance of that oxygen-enriched environment that can cause fire is significantly reduced. Yeah. But for years, they only give 100% oxygen.
Okay.
And so ECRI has been pushing vendors to say, you have air anyway. The unit has air coming into the back of it. So push that air with the oxygen here. And now most devices have some way to do that. And if you look here, it says auxiliary air /O2.
Okay.
So you can actually provide a mixture of gas and you can control the mixture. And that's been a key safety feature that vendors have been adopting and ECRI has been pushing them to adopt to reduce those incidents of surgical fire.
So Brad, you mentioned that we consider that sort of a key safety feature, I should say. I imagine that we must be evolving our testing protocols to account for that and other things.
Yeah, absolutely. So one of the things that happens in all of the devices that we test is as the technology as a whole gets better, our expectations move to match that.
Sure.
So a device that was 4 stars 3 or 4 years ago will go down to 3 stars as everyone else catches up to it. So that's what we're seeing here is this, we call it low vaporizer fill alarm. That for years has been a feature that is the difference between, I think, a 3 and a 4 star rating on the device. You can have a really good device, but if it doesn't have that feature, the best it's going to be is 3 stars. And that's been one of our key differentiating factors. But it's become extremely widespread now. And it's quite likely, we haven't made the decision yet, but it's easy to imagine that we're going to go from giving a device an advantage for having it to expecting devices to have it, and then giving a disadvantage to devices that don't have it. We'll expect, you just have to have this. This is an essential safety feature. So that's one of the ways we handle this sort of improvement of technology.
It's almost as an analogy, I think about automotive safety features, right? When airbags came out,
Right.
there was a luxury item.
Yep.
Now you would never step in a car that didn't have that built in.
It's exactly the same.
You raised a really interesting point with that, Brad, is that we're not just testing devices, giving a rating, and moving on, right?
Yep.
What is that interaction like with the manufacturers where we're giving them feedback that they can actually act on?
Absolutely, yeah, they do that quite a bit. I've found it maybe more as anesthesia than other technologies I've worked on, and it probably just a coincidence, but we have many times said to a vendor, it lacks something that you should do. There's a checklist that the American Society of Anesthesiology and FDA have developed over many years that you should do before every procedure. And the device does a lot of it, but they can't do all of it.
Right.
So there's some things like checking the backup bag or whatever. The device can't do that. And so, but we think because most of it's on the device, you should at least have a reminder on the device. And they didn't all do that. And so we called them out and they added it in. So in that situation, we removed the disadvantage and changed the rating. And the other thing is, vendors have, seen, oh, you gave our competitor an advantage for doing the low vaporizer alarm. We can do that. We're going to introduce that on our next generation device.
Right.
And then we give them an advantage for that. And so now the ratings change, and then eventually they all catch up and all the ratings reset and they all get annoyed at us because we've lowered their star rating. But it's because the technology has gotten better as a whole.
Right, yeah. Brad, thanks so much for sharing your time with us today.
Absolutely, it's been fun.
Thanks for watching ECRI Now. You can find more insights from the experts on YouTube and at ECRI.org. Until next time, I've been your host, Paul Anderson.